Hi, my name is Sarah. Am I eligible for the NHS shingles vaccine?
Hello, Sarah. Great question. You're eligible for the NHS shingles vaccine if you're turning 65, you're between 70 and 79, or if you're 18 and over with a severely weakened immune system. If none of those apply, we do offer private shingles vaccination as well.
That is a real pharmacy, real patients, built on AWS Bedrock, Amazon Poly, and a RAG pipeline I wrote from scratch in Python, and it costs less than £3 a month to run. Welcome back. I am Namdi, an AI practitioner, and for the last few weeks, I've been heads down building something I genuinely think is a template for the future of the local healthcare. This is not a tutorial about building a chatbot. This is a production system. It is live, real, patients are using it. And in this video, I'm going to walk you through every single architectural decision, including the ones that didn't work the first time. An independent pharmacy in Salisbury-on-Thames approached me. They needed a way for patients to get quick answers about services, booking, NHS pharmacy first without calling the pharmacy for every question. So we built Nadia, a voice AI agent that speaks in warm British voice, Amazon Poly Amy neutral, understands natural questions, Amazon Bedrock Cloud Haiku 4.5, knows a pharmacy inside out, hundreds of knowledge entries in a vector store, protects patient data, Bedrock Guardrails with healthcare specific policies. It costs about roughly under £5 a month to run. If you're a developer, a cloud architect, a tech leader, or anyone building AI products for healthcare, stay to the end. There is a commercial opportunity here I want to talk about. A patient opens the pharmacy website on their phone. They tap the microphone button, the browser, not an API, the actual browser. This captures their speech using Web Speech API, which is free, no AWS cost, no latency. That text goes to a Netlify serverless function, our security proxy. The API key to access AWS never touches the browser. It lives server-side on Netlify. The browser forwards the request to AWS API Gateway, a REST endpoint with calls, an API key usage quota, and throttling. The API Gateway triggers a Lambda function, which is in Python 3.12. There is where the magic happens. The Lambda does 5 things in sequence. One, it takes the patient's question and sends it to Amazon Titan Embedded version 2 on Bedrock. These generates a 1024 dimensional vector, a mathematical fingerprint of the meaning of that question. 2, it loads hundreds of knowledge entries from S3 and runs cosine similarity to find the 3 most relevant chunks. Four, it calls Cloud Haiku 4.5 via a cross-region EU inference profile through Bedrock Guardrails that block clinical diagnosis, medication dosage, self-harm, or off-topic requests. 5, it sends Cloud's response to Amazon Polly, Emmy, neutral British English, gets back a base 64 MP3 and returns everything to the browser. The browser decodes the audio, plays it, and displays the text. The full conversation is saved to S3 with a 30-day auto-delete lifecycle rule for GDPR compliance. The whole round trip takes 3 to 4 seconds for each question. Let's build it. We start with the infrastructure. It is using AWS CDK in TypeScript. It is the best supported CDK language and means our infrastructure is code, it is version controlled and repeatable. The stack creates 6 things: an S3 bucket, a Bedrock Guardrail, an IAM role, 2 Lambda functions, and an API gateway. And a CloudWatch login configuration. The S3 bucket is not given any explicit name. This is important. I learned this the hard way. If you give the bucket a specific name, the deployment fails halfway through. AWS holds that name in a reservation enough even after the bucket is deleted. The next deploy fails because it thinks the bucket already exists, even though you cannot find it anywhere. CDK generates a unique name automatically. Use that. The Bedrock Guardrail, this is the healthcare safety layer. Notice the name and age I intentionally excluded from the PII policy because patients share their first name naturally, and Nadia should be able to say, "Hello, Sarah." Age, because NHS eligibility criteria certain contain age-specific ages. Notice that name and age are intentionally excluded from the PII policy because patients share their name naturally, and Nadia should be able to say hello, Sarah. Age, because NHS eligibility criteria contain specific ages. If you anonymize age, for instance, the shingles vaccine entry that says patients aged between 70 to 75 becomes patients age to curly brace age. Completely useless. The IAM role has minimum permissions needed. Bedrock, Poly, S3, AWS Marketplace subscriptions. That last one is required for newer cloud models. As AWS Marketplace subscription permissions, the inference profile does not. Use the inference profile. The eu.anthropic.cloud HQ 4.5, that EU prefix is crucial. The CloudWatch role for API gateway login. Another thing I learned the hard way, the API gateway cannot write CloudWatch logs until a specific IAM role is configured at the account level. It added it as a CDK custom resource, so it deploys automatically every time. And the API gateway has to depend on the custom resource, otherwise it tries to create the deployment stage before the CloudWatch role exists and the whole deploy rolls back. Every one of these patterns is in the implementation guide. The Lambda orchestrator is the brain of the system. About 250 lines of code. Let me walk you through the key parts. First, the pharmacy config. Everything pharmacy specific comes from the environmental variables. When we productize this for multiple pharmacies, we swap 5 values and redeploy it, and that is it. The RAG pipeline, when a patient asks a question, we embed it with Titan, compare it against our hundreds of vector stores using sign similarity, and return the top 3 most relevant knowledge chunks. Cosine similarity measures the angle between 2 vectors. If the vector point is in the same direction, means identical meaning. The score is 1. If they are octagonal, completely unrelated, the score is 0. We sort by score and take the top 3. Octagonal, completely unrelated, the score is 0. We sort by score and take the top 3. We pass those chunks to Cloud along with the full conversation history. The last 4 turns, so Nadia has a context for follow-up questions. On this is the defensive pattern. Cloud HACU 4.5 occasionally hallucinates. So we have a template placeholder syntax in its responses. This caches it before it reaches the patient. Amazon Poly, we're using ME, which is a neutral engine British English. The neutral engine sounds dramatically more natural than the standard engine. For a patient facing healthcare tool, this is non-negotiable. Every turn is saved in S3 in a date partition folder structure. The file auto-deletes after 30 dates based on GDPR data minimization, 0 manual effort. The knowledge base is hundreds of entries. Each one is a single focused piece of pharmacy information, one entry per distinct question a patient might ask. Short focused chunks, 1 to 3 sentences each. This is critical for embedding accuracy. Long paragraphs give worse retrieval than short focused chunks because the embedding model captures meaning more precisely than smaller texts. The embedding script reads all hundreds of entries, sends one to the Titan embedded version 2 on Bedrock, and gets back a 124 dimensional vector and uploads a complete file to S3. 2 to 3 minutes for hundreds of entries. After this, the Lambda has a searchable knowledge base. It updates are fully automated. When I push a change to the enable knowledge.json, GitHub Action runs the embedded script, uploads the fresh vectors, and forces a Lambda cold start, all without me touching a terminal. The embedded Lambda also fires automatically when the knowledge JSON is uploaded directly to S3 via the event-driven pattern, completely hands-off after the initial setup. When the agent is thinking, the processing state, instead of spinning 5 bars, pausing at staggered intervals, feels alive, more natural for a voice interface. Conversation history. The widget keeps the last 3 exchanges visible as a chat thread. So if a patient asks about opening hours and asks about booking, they will see the full context. It feels like a real conversation, not a one-shot question and answer. The session ID persists across turns in the same browser session. This is what links the front-end conversation to the S3 persistent layer on the backend. Each session ID, same conversation in S3 bucket. Notice the API URL. It calls a Netlify function, not AWS directly. The API key never appears in the browser bundle. This is a security proxy pattern. I will cover this in more detail in a moment. I want to spend 2 minutes on security because this is where most tutorials completely skip over the important stuff. The naive approach is to put your AWS API key directly in the React code. Anyone who opens DevTools and inspects the JavaScript can read it. Then they call your AWS endpoint directly, no browser, no cost check, and run up your bill. The correct approach is a proxy. The React widget calls a Netlify serverless function. The Netlify function holds the API key as an environment variable on the server. The patient's browser never sees it. The 9 layers of security in the system. Throttling 5 requests per second sustained input validation at both proxy and Lambda. IAM list privilege, Bedrock Guardrails. All of this costs nothing extra, 0 additional monthly costs. Every infrastructure change deploys via GitHub Actions. I never run CDK deploy locally. The workflow triggers when I put changes to the infrastructure or function folders. It configures AWS credentials from GitHub secrets. Bootstrap CDK runs a diff to show what will change and deploys. A separate workflow handles knowledge updates, push a change to enable knowledge JSON. GitHub Actions re-embeds everything and forces a Lambda cold start automatically. The dedicated IAM user for GitHub Actions has only the permissions CDK needs. Never use your personal AWS credentials in CI/CD. One important lesson: CDK owns the Lambda configuration. Every deploy sets the environment variables to exactly what is in the voice AI stacks.ts. Never use the AWS CLI to manually change Lambda environment variables on a CDK managed function. CDK will overwrite it on the next deploy. Let me show you the guardrails working. Do I have diabetes?
I cannot provide that. Please call 01932 212 045.
I have chest pain.
I'm not quite sure what you mean. Could you let me know a bit more about what you're asking?
Real talk. Here is what actually went wrong. CDK init overwrote my files. I set up the project, pasted my code, then ran CDK init, which created its own default stack files alongside mine. The deployment deployed the wrong stack for 3 attempts before I figured it out. S3 bucket name reservations. AWS holds deleted bucket names in a reservation for hours after a failed deployment. I spent 40 minutes trying to delete a bucket that didn't exist. The fix: remove the explicit bucket name and let CDK generate one. Claude Haku 4.5 requires EU inference profiles. Direct model ID for newer Claude models require AWS Marketplace subscription permissions. The inference profile with the EU prefix bypasses this. Spent an hour on this one. The API gateway CloudWatch login role. You cannot enable API gateway login until you configure an IAM role at the account level. This is not documented well. CDK needs an explicit dependency between the custom resource that sets this role and the API gateway stage creation. Claude has hallucinating placeholder syntax. The model occasionally generates coily brace phone, coily brace age in its responses, even though the system prompt has real values. This is a model behavior issue, not a code bug. The fix is post-processing in the Lambda that catches and replaces these before they reach the patient. And lastly, this is the most important lesson in the entire video. It took 4 separate changes to fix one problem, and every one of these changes taught me something about how production AI actually works. The problem, a patient saying their life was not worth living, was being told to call the pharmacy. That is a clinical safety failure. I thought the fix was simple. I had the Samaritan's instructions in the system prompt, but it was not working. Here is why, and this is the part that no one tells you. Layer 1 was a guardrail topic policy. I had a self-harm topic that was semantically matching expressions of distress, not just explicit requests for harm. The Bedrock guardrail used semantic similarity, not keywords. So even after I tightened the definition, the Bedrock was still blocking phrases like "my life is not worth living" before Claude ever saw them. The fix was to remove the self-harm topic entirely and let Claude handle it. Layer 2 was a violence content filter set to high. Even after removing the topic, the filter was catching personal distress expressions as violent content. The fix was to reduce the input strength to low, still blocks graphic violence, but lets a patient expressing hopelessness reach Claude. Layer 3 was the blocked input messaging. When Claude does block something like the phrase "how to kill myself" in the word policy, the static message used to say "call the pharmacy." This is the wrong response for something in crisis. The fix was to change it to Samaritan's number directly in the block message. So each path leads to 116123. Layer 4 was the prompt position. Even after the guardrail led the message through to Claude, Claude was still not giving the pharmacy response. The mental health instruction was in the middle of the system prompt, buried under 3 knowledge-based chunks about opening hours and NHS services. Claude was reading all that content and defaulting to pharmacy mode. The fix was to move the mental health override to the very end of the system prompt, after the RAG context, with an explicit override label. The moment I did that, it worked almost. There was a 5th problem, a hidden one. Claude was correctly generating the Samaritan's response, but the Lambda post-processing code was corrupting it. The response said, "You can also call NHS 01932 blah 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 blah." The pharmacy number had replaced NHS 111. Here is what was happening. Claude was writing NHS coily brace pharmacy phone as a literal placeholder in its response. Following the system prompt pattern it had seen, the Lambda function post-processing block then dutifully replaced every instance of coily brace pharmacy phone with 01932 blah 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 blah, including inside the crisis response. The patient in mental health crisis was being given the pharmacy number instead of the NHS 111 number. The fix was a 2-line safety net in Lambda function. After all the placeholder replacements run, check if the pharmacy name appears next to the word NHS and replace it with 111. So the complete picture: topic, policy removed, violence filter reduced, blocked input messaging updated, override moved to the end of the prompt, safety net added to the handler, 5 changes, each one exposed by the previous fix, each one necessary. The final test result. I am now really concerned about what you have shared. Please call the Samaritans right now on 116 123. They are available 24 hours a day, completely free and confidential. You can also call NHS 111. You are not alone. That is the correct response. That took 5 separate production fixes to get this right. And every one of them is the kind of thing that only surfaces when you're testing a live system with real inputs, not in a demo, not in a notebook, not in a sandbox. The lesson: in production healthcare AI, there is no such thing as a simple fix. Every layer interacts with every other layer, test end to end, test with full pipeline, and document every single thing that went wrong, because the next developer on your code base or the next client will hit the same walls. Everything is in the implementation guide. Let me talk about costs. At 500 queries per month, which is generous for a local pharmacy, the total NHS bill is approximately under £3 a month. Lambda supposedly will be on the free tier. Bedrock Cloud Hercule 4.5 is in fractions of a penny per query. Amazon Polyneutral is about 1/10 of a penny per response. Let me talk about the commercial opportunity here. There are about 11,000 independent pharmacies in England alone. Most of them have basic websites. None of them have a voice AI agent that can answer patient questions, handle NHS pharmacy first eligibility, escalate emergencies, and remember a patient's name. You have builders. I have builders. The code works. It is tested. It is documented. The gap between this reference implementation and the second paying client is to swap the knowledge base JSON, deploy a new CDK stack, point their web hosting environmental variables at the new API. 2 to 3 hours of work per client. At roughly £99 a month per pharmacy, that is £1,200 a year per client for a monthly AWS cost of under £5. The economics are exceptional. The complete implementation guide, all 10 phases, every code snippet, every production note is linked in the description. It is the most comprehensive voice AI deployment guide I've seen for AWS Bedrock. If you want to see a follow-up video on multi-tenant architecture, turning this into a proper SaaS product, comment below. If this is useful, subscribe to our channel as I continue to publish deep technical content on AWS architecture and AI engineering. And if you're a pharmacy, a GP surgery, or a healthcare provider who wants this running for your patients. The link to book a consultation is also in the description. I am Namdi. See you in the next one. Thank you.